Hey, this is Dr. B, and I thought it would be handy to actually show some three-dimensional graphs or two-dimensional comparisons that really illustrate some of the periodic trends. Let's repeat what they are. The size tends to increase towards fluorine. Each column tends to have similar properties. Melting points tend to increase as you go up a group 1. Melting point tends to increase as you go down group 17. I'm not explaining the whys for this, I'm just showing some of the trends. Mass maxes out towards the bottom right-hand corner with oganesson. Electronegativity increases as you head towards fluorine. Be careful not to extend that all the way to the noble gases since they have no desire for electrons. The electron affinity, which is the energy released when it gains an electron, also tends to go in the same direction, as does the ionization energy, the energy to lose an electron. They all increase towards fluorine. Let's take a quick peek at some of these trends so we get a feel for them. There's size, looking pretty good as we're heading towards francium. Here's electronegativity. That is the desire for the electrons. Fluorine maxes out. I would say they removed the noble gases there to keep things simple. These want to gain electrons. These do not at all. They want to lose electrons. If you take an ion, the trend isn't that different. You can parse out the reasons for some of these other differences in terms of them losing an electron or gaining, but we see a very similar trend to atomic radius. This is an interesting graph here which shows the atomic radius and then the ionic radius, which is an interesting thing to look at. And I believe that it's getting smaller for the cations, but it's getting larger for the anions since they're gaining, these are losing. Energy released when an atom gains an electron is shown here. This is called electron affinity, and just like it does for electronegativity, the trend maxes out for fluorine, and the charges are largely blank for the polyvalent region. Isn't that interesting? This is a great look at the polyvalent ions. These ones may have some polyvalent nature, but it just hasn't been observed yet, so they're largely observed to be monovalent. All the other ones are just one charge only. Since these ones have multiple charges, then technically these are the ones that you should name with Roman numerals. All the other ones, it isn't strictly necessary. That's a common question. When do I use those Roman numerals? Okay, that's a look at periodic trends.